Thank you, everyone. We have 2 more workshops that will be taking place before the end of the day. I would like to start by introducing you to Matteo Maccia, Power Solutions Engineer, European Sales Operations at Keysight Technologies.
Thank you. Thank you.
We will be discussing accelerating the development of EV cells and batteries. I'll leave you the stage.
Thank you. Let me find the clicker. Okay. Welcome, everybody. I'm again Matteo Mascia. I work for Keysight as a power solution engineer for e-mobility, and today I'm going to talk to you about the accelerating development of EV cells and batteries. Just a few words about Keysight Technology, which is a multinational company with more than 150 locations across all over the world and almost 1,400 employees. It's a company derived from HP, so since the 1939 we have decades of experience in test and measurement environment, and of course also in battery and EV testing, as you will see in the presentation today. We have a portfolio of more than 5,000 products, and so let's say again, we are into the industry. Regarding the Keysight EV test solutions, we cover with our products and solution almost all the technologies around the charging, the e-mobility infrastructure, I would say, starting from charging technologies to testing inverters, testing cells and batteries, BMS, and so on. As you can see, and as an example in the image above, there is, let's say, a test lab filled of Keysight battery testers, and on the bottom, we have, let's say, a demo setup for charging setup for charging of electric vehicles. Then what's the today's topic? We'll talk about the impact as the EV are becoming mainstream. So as you know, let's say the market is asking for more and better batteries to basically improve the EV experience in terms of range, in terms of recharge time, and also in terms of price. So for reaching that goal, we of course need a lot of innovation in the battery field, especially in the power density of the battery itself. Of course, we know that we will have more batteries, and of course we will need more factories, and as a consequence, more testers and more data to be acquired and analyzed to gain insights of new batteries, let's say. So, what are the challenges? What are the challenges in the development of the EV, of the new generation of EV cells and batteries? First of all, the battery manufacturer needs to adopt improved measurement technologies to gain deeper insight into cells and batteries, of course. This I will treat like these bullet points as an agenda, so I will cover all these points that you can see here. And so we need also to manage the growing number of test systems in the R&D laboratories, and of course manage the huge amount of data that it's flowing. It needs to be acquired, analyzed to again gain insights and develop the battery of the future. As the number of batteries increasing and the power per each cell is absolutely increasing, we will also discuss about how to efficiently use the energy during the intensive testing of all the cells. Let's start from the first point, so how to adopt improved measurement technology for gaining insights on the cell and batteries. The first topic is the self-discharge of a battery. So as you may know, this is a crucial, let's say, parameter to be evaluated for discriminating a bad cell from a good cell. And this is the traditional way to do it. So we can measure the open circuit voltage, then we can put the cell into a temperature controlled environment and wait a couple of days, because the lithium cell has a typical discharge of 1 or 2% per month. So it's pretty slow. And so once we have those two voltages, we can use those values for basically determine and calculate the capacity curve, and again calculating the self-discharge current, which is the main parameter to be evaluated. There is another way to do it, an innovative way to do it, which is patented by Keysight, and we can do like an analogy. We can say that the self-discharge of a battery, it's basically like a water leak. As you can see, the barrel is the battery and the water is the charging level. So of course we can measure the difference of the level of the charge itself, in this case the water, to then assess how big is the leakage of the battery. Then there is another way, which is called potentiostatic method. So instead of measuring the level of the water, we can fill the tank itself with the same amount of the water that it's been leaked out. So with this, let's say, process, we can directly measure the current of the self-discharge without waiting time, let's say saving a lot of time. Again, this is a solution that has been patented by Keysight. What we do is basically measure the cell voltage in a very precise way into a microvolt, and then we keep the voltage of the cell constant while feeding the cell with the correct amount of current. This is something that needs a little bit of time, needs to be stabilized, but once it's stable, we will see in the next slide. So we can say for this kind of cell, which is an example, that it's a test of the 18650 cell, within 15 minutes we are able to understand if the cell is good or if the cell is bad. And the stabilization of the processes in this case happens after only 1 hour. So as you can see, it's stable, so you can make the measurement and then discriminate which is a good cell to go, for example, on the automotive environment, which is a bad one that can go for other application or needs to be again thrown away or recycled, I would say. This is another example of a result of a self-discharge measurement using the potentiostatic method on a larger pouch cell. In this case, it's 270 amp hour. And I let's say, put this graph just to highlight that the dependency on the temperature, it's pretty high. So of course, let's say an algorithm for temperature correction is absolutely needed, and it's possible to do it in both potentiostatic method and delta OCV method, as I was saying before. Okay, let's come to the product. This is the Keysight product, which is able to, let's say, measure the self-discharge using a potentiostatic method. Again, it's an innovative technology, and it's being patented by us, and it can go up to 32 channels. But of course, you can also place multiple of these systems in parallel to achieve more channels. Again, for measuring this kind of leakage current, you need really high accuracy, and we can achieve the measurement from 10 microamps to 10 milliamps, and of course the accuracy it's pretty low. It's 0.3% plus 250 nanoamps. Let me switch topic and talk about another method to gain insights about let's say, what's inside the battery, what's happening inside the battery during a charging and during the battery usage, which is called electrochemical impedance spectroscopy, which I will call EIS from now on. And what it is, it's basically a non-invasive method that uses a small sinusoidal current to stimulate the cell over a different range of frequencies. So what you do, basically, you apply a sinusoidal current, and then you measure the voltage response for each frequency. And so the output of an EIS measurement is basically a Nyquist plot in which you can see the impedance of the cell on different frequencies. And why is it useful? It's useful because it can be used for assessing different type of behavior inside the cell, starting from assessing the state of charge. We will see in the next slides that, let's say, the EIS result will shift based on the state of charge. But of course, we can also examine the different physical reactions that are happening inside the cell, again, in a non-invasive method. So it's not needed to open and destroy the battery to understand what's going on inside. This is a typical result of an EIS process, and again, the result is based on lithium-ion. This is the curve, the red one. It's based on lithium-ion result. And as you can see, the physical processes are distributed across different frequencies. Starting from the higher frequencies on the left, you can appreciate the inductance of the wires and the cell structure effect on the higher frequency. Then there is the double layer charging at the mid frequency around 100 Hz, which are followed by the resistive charge transfer, so the real charge transfer at 1 to 100 Hz. Lowering the frequencies, there is the material diffusion. So this, let's say, the material diffusion processes can be appreciated at the electrodes. And so, let's say, an R&D people that develops the battery, if they see this graph, they perfectly know what they are talking about. These are two examples just to give you let's say, better understanding what are the dependency of the EIS result. On the left, you can see the same curve is shifting based on the state of charge. As we can see, lower is the state of charge. In this case, higher is the internal resistance of the cell. And so if you know the curve, the EIS curve in advance, you can use the result that you have to assess the state of charge of a cell. On the right, you can see that there is also a dependent on the temperature. And so that's also the reason why the batteries of the cars behave different based on the temperature, and they are also, of course, temperature controlled. And as you can see, increasing the temperature stretches a little bit and let's say the waveform here. And so just to say that it's pretty much dependent also on temperature. Another crucial aspect of the EIS, it's the calibration process. To achieve those kind of results, the system needs to be accurately calibrated. Or if you don't do it, basically you cannot separate the DUT behavior from the measurement system behavior, which is something that you don't want, of course. And let's say it is just an aspect that it's worth to mention, let's say. So, the EIS in our, let's say, in the Keysight battery tester, the EIS is pretty much implemented in almost all the products and can be, let's say, can be adjusted in a broad frequency starting from millihertz to up to 30 kilohertz. And of course, the calibrated and accurate EIS achieve resolution up to microvolt. Again, the calibration, it's a crucial aspect for this, let's say, for these results. So we touched the first topic. Let's move on talking about how to manage the growing number of test systems in the R&D labs, and of course, as a consequence, also how to manage the huge amount of data that will come from the new testers, and let's say that needs to be acquired, of course, analyzed, and to gain insights and to build the batteries of tomorrow. Which is the current status? Basically, the test laboratories now have thousands of channels for cell and battery testing, and they should also manage the growing number of test systems. And the gap now it's how to utilize the test assets in an efficient way, because let's say the demand is increasing, and let's say you need to use the same resources in a better way. Of course, the current and standard tools for assets utilization, which is like, let's say, whiteboards or Excels, may not be sufficient for the scope. And so also, let's say, another gap, it's that, of course, you need to access a massive amount of data that are generated all over the thousands of channels. So for this kind of, let's say, for fixing and to addressing this need, Keysight has developed a software which is called Pathwave Lab Operation for battery testing, which, let's say, it's helping to manage all the resources in the laboratories, including the test facility, test system, DUTs, and it's also enabling efficient planning and coordination across all, let's say, the entire batteries, DUTs, and laboratories itself. It has, let's say, a web-based user interface for the whole lab management. Last but not least, it's not the last, one of the last points is how to use, let's say, one of the challenges is use the energy in an efficient way during the intensive of test. As you, of course, know, first of all, the test lab are growing in size, and the test that you need to perform on cells and batteries are becoming pretty long. So you can, let's say, have a test that it's during days, weeks, but also months. It's depending on the test. And of course, the new technology is developing larger batteries and larger cells that need more power per cycle. So in the end, you will need to have in the laboratory a lot of more power than before. So there will be more energy consumption, and with more energy consumption, you have to deal about the higher test cost because you spend more energy. And again, there is also more heat in the lab, but that it will be fixed through the water cooling. As an example, here we have 3 columns. In each column, it's representing a different type of laboratory. There is a small laboratory on the left, a medium laboratory on the center, and a large laboratory on the right. Starting from 500 and something kilowatt, then there is 2 megawatt lab, and then 10 megawatt lab. As you can see, the cost of the energy, it's pretty high. And again, if you look below, you can see that if you save only 1% of the efficiency, so if you increase the efficiency only by 1%, you can save thousands of euros or dollars up to hundreds of dollars, depending the size of the lab. And for addressing also these needs that it's becoming, of course, more high, Keysight has developed a battery pack test system which can go up to 1,500 volt, and it's used, of course, for testing, mainly for testing battery packs of the cars. It's 10 kilowatt, 200 kilowatt, or 300 kilowatt version. It has a small footprint because it has silicon carbide technology. And as you can see from the slide, there is 96% of efficiency. And this means that from the power that you get from the input and the power that goes from the output, you only lose the 4% in the heat, which is pretty low, I can tell you. So, last but not least, how to grow the test engineering capabilities while additional qualified people are coming up to speed. Okay, the laboratory are increasing in size, so we expect that more engineer needs to be hired, and let's say they need time to go up to speed. What we propose to the market is to leverage from the expertise of Keysight to acquire and deploy turnkey test solutions. We can work from the requirements, from the customer requirement. Then we normally, once we have analyzed the requirement, we propose a solution, which is a solution composed of Keysight part number, but also third-party part numbers. And we write a statement of work. It's a paper which, let's say, summarize all the technical aspect and the project aspect we are discussing with the customer, and then we have a dedicated team of project manager that can follow the customer through all the process, and we can also take care of third-party acquisition and integration on our test systems. Of course, the support doesn't finish while the selling has been done. So we are committed also for post-sales services like calibration, training, and maintaining all the hardware with software and hardware updates, of course. So just to give you an understanding on which are the kind of test system that we deal with. We can, we have products and solutions that covers almost all the aspects of a battery development. So starting from cell prototypes, we have specific products going to normal cell and test validation of the cell, test and validation of the modules, and also on the packs. There are dedicated solutions for each, for each of these products, and of course also climatic chamber and fixture and whatever it's needed around for making it working, we can absolutely provide it. So I'm going to finish. So one of the last slides as a summary, We can say that let's say with our test solutions that can, let's say, we can have innovative measurement technologies, and with the highest measurement accuracy and dynamics, we can of course help the customer in this kind of process in, let's say, in accelerating the development of the EV cells and batteries. Of course, as I was saying, we have software for improving the workflows, and our tester has super high efficiency, up to 96%. And as I was saying, you can leverage from our expertise with OEM and battery makers and car makers for all around the world to develop and let's say, and deliver customized turnkey test solutions. This was my last slide, so thank you for the attention, and I'm available for any question if there is any.